All right, Algebra 2 students, we are back at it again. We are going to finish up these last couple ones for characteristics of relations and functions. If we were in class, we would do this with our TI Nspires, but we can do this with Desmos. It's really, really easy. This says provide information about the equations given below. So we have two equations. One is an absolute value equation. One is a square root equation. We're going to fill in the tables, and we're going to sketch the graph. And then we're going to answer a couple of questions. Okay, so two little problems, and then we'll be done. So this first one says 2 times the absolute value of x minus 1. You see that? It says complete the table of values. Now, you could take this negative 3, plug it in for x. Negative 3 minus 1 is negative 4. Absolute value of negative 4 is 4. 4 times 2 is 8. You can put an 8 there. Or you can go to your friendly Desmos graphing calculator, and you can type in this equation. It is 2. Now, I opened my keyboard. There's a little keyboard down here. Yours might be hidden, but there's a keyboard right here. And we type the 2. You see right here, absolute value with the little bars. What is that? X minus 1. So x minus 1. Now, it's doing the graph for you. We're going to sketch that in a minute. But you can see what it did with that graph. So 2 times the absolute value of x minus 1. Now, your paper asks for the table. In Desmos, you click the little gear, and here is convert to table. Now, this table starts at negative 2, so you could fill in negative 2 and 6, negative 1, 4, 0, 2, 1, 0, because that's what's on our table on our paper. Our table on paper has negative 3. We don't have negative 3 here, but watch what you can do right here. Negative 3. And it fills it in automatically. Any other numbers that you wanted? If you wanted to keep going past the 2, 3. Uh-oh, that didn't work. 3, 5, 12, whatever you want. You can put in whatever numbers, and it just fills in your table for you. So there's the table, and here's the graph. Okay, so let's look back at our paper because we want to analyze this graph a little bit. Okay, so here's the table. I don't know if you guys were able to print this out or if you're writing it down on paper or if you're just watching the video. Any of those ways is fine as long as you understand how to navigate around these, what these words mean, how to answer these questions. Okay, so our table here was 8. 6, 4, 2, 0, 2, 4. You notice what those numbers do? It went 8, 6, 4, 2, 0. So it's going down, 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 and then it goes back up. What did we say the shape of an absolute value function was? We said that shape was a V. All right, here's the graph. Now you could sketch it from what you saw on the calculator, but let's look at our points. We have negative 3, 8, negative 3, 8, and negative 2, 6, and negative 1, 4, and 0, 2, 1, 0, 2, 2, 3, 4. Now it looks like a backward check mark. Now, I know we've talked about continuous and discrete. When you are given an equation like we had here, one more time, Rodell, you cannot write with that. It's too fat. Y equals 2 times the absolute value x minus 1. When you have that equation, I didn't have to write that because you can see it. when you have this equation, if you scrolled up and down in that calculator, we typed other numbers in, it would give you all kind of points. These are not the only points that are in this table. This is only a portion of it. But when we type in that equation from your calculator, you can see there's lots of points. You could scroll up and down all day long and get points. On Desmos, you could type numbers in all day long up to negative thousands and whatever and get points. This is continuous, so we're going to connect these points. We know it's continuous because they gave us an equation. A short way to say that. Okay? So we have the table and we have the graph. Now, let's talk about domain. You know what? I'm going to write these out to the side because if I move that up, you're going to lose all that writing. The domain, because this is an equation, it includes all those points. Look, there are arrows on the end. There's no stopping point to the left, no stopping point to the right. So the domain is all real numbers. If we're going to write that in an inequality like we did on the other page, it goes from negative infinity to positive infinity. The range, what's the lowest y value? The lowest y value is 0. And the highest y value is infinity. You could also write that as y is greater than or equal to 0. There's two different ways to write the range. Okay. We already talked about if this is continuous. If they give you the equation, then the data is continuous. Those points are connected. What parent function best represents this data? You can tell that from the equation because it has the absolute value bars. You can tell it from the graph because it looks like a V. It is absolute value. Okay. Absolute value we know from the shape of the graph or we know from the bars in the equation. All right. One more. And I'm going to, I guess we can leave that. This one is 2 times the square root of x plus 1. So you can already tell like what kind of parent function it is, but we'll look at the graph in a minute. Complete the table of values. So we can go to Desmos. I'm going to have to take all that writing off to change tabs. And we're going to close out this one. And this equation is 2 times the square root of x. Again, that's in that little keyboard that's down at the left. Uh-oh, I don't want 2 of them. X plus 1. There's your graph. Remember that square root function has an endpoint. This one has an endpoint. Desmos also, you can, if you just land on that point, it'll tell you what it is. There's the endpoint. You can land on this point. You can land on that point. It'll tell you what they are. It's pretty cool. So it has an endpoint there. We can get the table. Now, notice this table starts at -2, and the one on the paper starts at -2 as well. What does the table say at -2? It says undefined. Why in the world would it say undefined? Well, let's look. What happens in the graph where x is -2? There is nothing there, right? That function doesn't extend to -2 because the endpoint is at -1. That's why it says undefined. And that's going to happen with your square root functions because they have an endpoint. They don't keep going both directions. They have an endpoint. So anything that's past that endpoint that's not included is going to say undefined. If you have a TI 84 or 83, it might say error. If you have an Inspire, it says undefined. Desmos is going to say undefined. Okay, here are our other points. The ones that are on the paper, if you printed it out, are -2, -1, 0, 3. Oh, I didn't want 4. 8 and 15. Isn't that cool the way you can just type those x values in and it gives you the y? So there are our points for this function. Okay? 2 times the square root of x plus 1 There's your graph. Look, notice when we put these points in the table that they showed up on the graph. Okay, I'm going to go back to the paper. And it says complete the table of values. It's nice to have a handy dandy answer key over here. This said undefined. -1 was 0. This was 2, 4, 6, and 8. Okay, and then the graph. You can sketch it from the calculator. It's much more accurate if you plot the points. So we're going to start with -1, 0, and 0, 2. Headphones are slipping off. 3, 4, 8, 6, and 15, 8. Because they gave us the equation, this is continuous data. We would connect the points. Has an endpoint on the left. It keeps going on the right. The questions they ask us, domain. Where did the x value start? What's the stopping point or the endpoint on the left? It is -1. I'm just noticing the key says 0. It's wrong. The range is y is greater than or equal to 0. Is it a function? It is a function because it passes the vertical line test. The x's don't repeat. Each input has only one output. Passes the vertical line test. Continuous or discrete, because they gave us an equation. The table is only a portion of the points. This is continuous. And what parent function best represents it? It had one of these in the equation, right? The variable was underneath the square root sign, so this is a square root function. Very good. See you in the next video.